Alright, here's a video for the finite element lab, and this will be the final uh, results of your project. So we'll be doing a simulation on the CAD we just made in the midterm. Alright, so you can take a look at the final results. Okay, so what we do is, well, this results is not necessarily right, but we'll show you the right results when it comes. Anyway, so the setup is we apply two forces on the handle. We have a nylon bar here to squeeze, and we fix constraint here, and we do have another constraint here. The reason being is because the texture is there's a special property of texture, so we needed extra constraint here. Anyway, so that's the setup. Then you will get results similar to this, but not exactly the same number. Then that should be the final results. Okay. Alright, so let's turn it off. Let's start the fan. Okay. Alright, so the first step, you will need to download the CAD from web course. Okay. And before that, let's talk about the schedule. So we probably have 4 labs, and all the schedules are here. You can take a look. Alright, so download the CAD. You need to download everything into one folder, okay, which will look like this. You have 4 files, and one of them is the assembly. Okay, so we'll open the assembly, and this one is simplified assembly, and it's a little bit different from your model. If you want to do the analysis on your own model, you need to take out some fancy stuff, make it easier for the simulation. Okay, so how do we start the simulation? Now we are in the assembly, and that is actually modeling. You can see from here. Okay, so first we need to switch to advanced simulation mode. So this is one of the modules in NX, and now we're in the advanced simulation application. Then it'll automatically take us to simulation navigator. So what you need to do is just right click here and create a new FEMA simulation. Now here it should be everything default, and just make sure you need to have create idealized part checked, and this is analysis type should be structural. Then it'll create a sim, and in the sim it'll ask you what about the solution. Just do a default solution, say OK. Then take a look at here. You have 4 files. The first one, the bottom one, is the assembly. Then we have a sim and a fem, and there's one called idealized part. It's the I part, which we're gonna start with. So the idealized part, there's a little bit explanation here. Let's go to idealized part first. Well, let's go to the sim. So the sim will give you the final results. So that's like the final part of final step of your simulation. And in this chart you can see we started from the CAD, then we create the idealized part, which is for the FEM. The FEM is not directly based on the assembly, it's based on the idealized part. So in the tree you can see the sim is based on the FEM, and the FEM is based on your idealized part. The idealized part is based on the CAD. Why NX does that? Because your assembly is for manufacturing, and you don't want to change anything on that. So when you do simulation, you create a copy of your CAD, which is called the idealized part. Then you can do all kinds of simplification, modification on the CAD without changing your manufacturing. Okay, so then you do simulation. So from the tree you can also tell. Alright, so we'll go to the idealized part, and here you can see from the top it's in ideal, okay, I.prt. So that's the idealized part. The idea is we need to find the mid surface of the handle to do a 2D mesh. Okay, that's the only thing we need to do here. So yeah, make sure you're in the idealized part. Alright, so the first thing is not to find the mid surface. Actually, the first thing is to promote the part. So without promoting, you cannot modify anything. So promote and pick this handle. Now next step, it's already promoted. If you want to take a look at it, you want to make sure you can go to Part Navigator, and you can see it's promoted, which is we can edit that. Then mid surface by face pair. Pick the handle, and as you can see, we cannot pick anything else because they are not promoted. And alright, so in mid surface, we need to change the strategy to progressive. Then just simply click this button. It'll create a mid surface. If you can see that line in the middle of the shell, then you can say OK. Alright, so that's the mid surface. I selected that in the slides so you can see it. Alright, then we need to split the handle into top and the bottom half. The reason is this is symmetric on the top and the top and the bottom, so we can mesh just the top half. Then we will do a reflection to the bottom. This way we'll make sure the mesh is symmetric. If you don't do that, you mesh the whole thing, it's not symmetric. It's funny, the cat is symmetric, but the mesh will not be symmetric. You can try it. Okay. Alright, so we can do a split body, and if you click here, that'll be a solid body, not the mid surface. Okay, so the trick is zoom in and pick the just right click, select from list, pick the sheet body. Okay, and I have two objects here in the slides, is because some people a lot of people are having a hard time selecting the sheet body. So I would say just click twice here, then you have two objects. Now you know the mid surface is definitely selected. Alright, then the tool, we need a new plane that should be XY plane because it's symmetric on XY plane. Okay, so once you cut, the solid body gonna have different color, and if you want to, you can probably hide the promoted body, then it'll leave us the sheet body, and because it's cut in half, the top doesn't belong to the promoted body anymore. So you can select from list, also hide it to see your mid surface. You don't have to do this, just be nice to see things. Okay, then we can go back to the FEM, and it'll tell us your polygon has changed because we just cut something in half. It'll increase the number of polygons in the simulation navigator, and because we just hit something, we're gonna have less polygon numbers. So probably you're gonna have all if you don't hide. So I'm going back to the idealized part. I'll show the show everything, show solid body, and go back to the FEM. Now how many polygons we have? We have 8 polygons if you don't have anything hidden in the idealized part. Okay, so we don't need to use all of them, we can hide them and find the mid surface. So we just need the top half of the mid surface. Okay, now this is in the FEM, by the way. Okay, so here they are multiple faces. If you do a mesh right now, it'll give you separated meshes. So we want to merge those polygon faces. And here's merge face. And the first one is delete the edges. You cannot box select. So we do the second one. It's you pick faces, it'll merge for you. So here we can do a box select, then select everything, merge everything together for the top half. Okay. Then next we just go ahead and mesh this using 2D mesh. C=4. The element size is 0.05 inch, and do OK. Alright, so we have mesh on the top half. Now we don't need the polygon. It is very good habit to turn off the polygon body once you're done with them. Okay. I guess a lot of you have applied forces or constraints on the polygon body because you haven't, you didn't hide the body, polygon bodies. All right. So the next step is we're gonna mirror this mesh onto the bottom side. So we do insert, element, copy, and reflect. Okay. Sometimes it says reflect, sometimes it's called a mirror. So we select everything. You might have different numbers here, the elements, because some of my computer, well, if your number of elements are far off, that means something's wrong. You might mesh the solid body, not the sheet body. Okay, check your mesh. Then the symmetry plane here is XY plane. Okay, we'll do apply. That'll give you the bottom half. Okay, then we can select all of them and reflect to the other side, to the right side. Now this time it's the YZ plane. Okay, the CAD model is symmetric on the YZ plane in terms of handles. The jaws, that's different story. So that is the two handles. You can turn on polygon and compare to the polygon and turn them off. Alright, so if you like to, you can select one half and change color by editing the display, and you can change colors. Okay. The next step, we're not done with the 2D body yet because we reflected them. They are still two separate pieces in terms of the mesh. So if you do a simulation, they're just gonna split. So how do we tell they are not connected or they're not a single continuous piece? We have a tool called element edge. So the element edge, it'll show the external edge of mesh. So you can select these two pieces. Those two are the same, but we can select them both. Then we do a create element outline. So outline means external edges, right? Now you see there's one line in the middle of the handle. That means your handle is actually two pieces, not connected. So what we can do is we do a duplicated nodes. Why there are duplicate nodes? Because when we do the reflection, this edge, the bottom edge, or the edge between those two pieces, they are reflected twice on the same location. So you have two nodes at the same location. So this line is full of duplicate nodes. Then we merge them, and we'll do the same for the other side. And I'm pretty sure you cannot select the 3 because those are duplicated. Okay, but they need to be duplicated. They just happen to overlap there. So we have only do this for one side at a time. Merge the nodes, and okay. So to be safe, okay, I know they're merged, but to be safe, you can do the element edge again. Show external edge. There's no line in the middle. So that's good. We'll turn this off. You see the blue lines. What you can do is right click and refresh. It'll hide the it'll clear the blue line. And let's see what's next. So we're done with the 2D mesh. Then next we're gonna create the 3D mesh. So you can uncheck 2D mesh, check the jaws. So we have two jaws. They're not symmetric. They're like a rotated about y-axis 180 degrees. So in the slides I said you can do is mesh one, then reflect twice to the to make this one. I guess you can also just mesh both of them straight. So do a 3D texture mesh. We're gonna use C texture 10, which is, you know, C texture 4 is linear texture, is terrible. So unless you know what you're doing, don't use that. And the element size is 0.05. We'll mesh this first, or rather you can mesh either one first. Apply. And if you feel two reflections is too much work, you can go straight and mesh the other one. So the reason I'm doing reflection is make sure those two pieces of meshes are exactly the same. Okay, as you know, meshing is sort of a random thing. This might be tiny difference between even two pieces of the same CAD at different location. So we do a reflection first, copy and reflect. It will not get the other side, but it'll get one step closer. Alright, so you can have a different number of elements. It depends on the computer setting and how long you have been using NX. Sometimes you change one setting, it'll change the mesh. So the symmetry plane, first time I'm gonna reflect to the other side, left to right, right to left, and this be YZ plane, apply. So now this one is on the, let's say it's on the right side now. Okay, but if you turn on the polygon, it's actually flipped from where we want. So what we can do is, first you want to hide the original copy. This way you don't select that. Then you select everything, and we can reflect again about the XY plane. Okay, so do another reflection. And it takes a while. Then you can hide the second mesh here, which is the first reflection. Show the original mesh. That's that'll finish the jaws. So for this first reflection, you can simply delete that. We don't need that anymore. So these are the 3D textures, and again, you want if you want to color code your mesh, okay, you can do that. Then next step is the material and the thickness in terms of 2D mesh. So for the 3D, we don't need the thickness. We just go to P solid and change that to steel. So the material here is steel. Okay. And for the 2D mesh, we need to do one more step. P shell 1, material is steel, and make sure you only assign material 1. Material 4 is done, and don't touch that. Default thickness 0.075. Okay, take a look in the slides and say okay. Now, since this is a video, I'm gonna show you a little bit more stuff. So how do I know how thick this 2D shell is? You can look at that into the material property, or you can edit display, and you can check this element thickness and offset and apply. Now you can see the shell thickness, but usually we don't want that because it looks like a 3D elements. So just show you we have the capability to see the thickness of 2D shell, right? And that'll be it for the first FEM lab. So the next lab we're going to assemble those meshes together using spiders, C-bars, and the C-bush. It'll enable the rotation degree of freedom for those things. All right, thank you.